Yeah, good afternoon. Today I'm going to discuss about the additional features of a ER diagram. Myself, Dr. T.S. Srinivas, working as Associate Professor in CSC Department in MLR College. So, in the last discussion, I told about the ER diagrams. So, today we will be discussing about the additional features of ER diagram. So these are the course objectives. Understand the fundamental concepts of database and DBMS architecture, develop SQL queries, apply DBMS to solve the real problems, and course outcomes will explain the basic concepts of DBMS, evaluate the database models, apply the architecture to the databases, design the database models using the ER diagram. So in unit 1, these are the different topics. So today I'm going to discuss about the additional features of ER and conceptual design with ER diagrams and entity sets, relationship and relationship sets. So these are the different textbooks we have followed, Sudarshan and Navate and Ramakrishnan and Garrick. So what is entity set, relationship set and attribute? Entity set are those sets. Suppose in a relation, we are having a relation between the two entities. This is entity 1 and this is entity 2. So if all the attributes of entity 1 and entity 2 are going to participate in the relation, then that attribute that is called as a strong entity, as I told in the last discussion, strong entity and also the entity set. So if all the attributes are going to participate in the relation, then it is called as the entity set. So what are the different relationships? Suppose if all the attributes of one entity are going to participate in the relation with all the attributes of another entity, then it is many to many. If one or two attributes of one entity are going to have the relation with all the attributes of the entity set 2, then it is called as one to many. If many attributes of entity set are going to have relation with one attribute of entity set, then it is called many to one. If one attribute of entity 1 is going to have relation with another attribute of entity, one attribute of entity 2, then it is called as a one-to-one relationship. So relationship sets are 4 types, and attributes, for each entity we are having the attributes. If all the attributes are going to participate in the relation, then it is called as a strong entity. So what are the additional features? Additional features, when I come to the discussion, we are having some additional features: specialization, generalization and aggregation. These are the different additional features. And conceptual design with ER model, that will be explained later. So what is the purpose of the ER diagram? The purpose of the ER diagram is to understand the system data requirements, design structured databases, reduce redundancy and improve data redundancy, data consistency, and easy communication with stakeholders. So how can we use the ER diagrams? So we are having one ER diagram here. This ER diagram is having some attributes, and all the attributes are represented with ovals. If I am going to specify this as a student entity, then student ID, we have given as a underscore, so that means it is a primary key. So we are going to reduce the redundancy by specifying the relation between the two entities, and for this entity also we are having some. So suppose this is a faculty, the faculty ID is a primary key. So we are having two primary keys. Whenever we are having the primary keys, that particular entity is having the data consistency, is maintaining the data consistency, and we are reducing the redundancy. So here the student number is there. So here also there is a student number. So in this table, student number, we are specifying as a attribute. Here we can specify it as a candidate key. Okay, so candidate key is primary key plus some other attribute. So if you are going to specify like that, so in faculty table also the student number is there. The student number will be the candidate key. So primary key plus another attribute, so that will become a candidate key, right? So in that we can reduce the redundancy of that particular ER diagram. So we can improve the data consistency. Yes, definitely. Here the student ID is there. Here faculty ID is there. So each table is having its own data types, its own attribute followed by the data types. So the table will be created without any inconsistent data. So here the table in ER diagram, whenever we are going to create the table, we should be specific with two values. One is called as a null values and not null values. So these two are null. Null means there is no value. Not null means compulsorily that particular attribute should have some value. Suppose if I am going to declare student ID as a primary key, then we should, whenever the student ID attribute is created, so we have to give the student ID primary key, primary underscore key. We have to give not null. Not null means compulsorily that particular attribute should have a value. Okay, so we can specify the data type as varchar2. We can specify the varchar2. So that is student ID is a combination of student ID is a combination of both numeric and non-numeric numbers. So we specify 247Y1A0501. Suppose we are specifying like that. So it is a combination of numeric and non-numeric and characters. So whenever you are going to have a key value of this type, we should specify the varchar. So by specifying the data types, all the inconsistent data will be removed, and we can only enter the consistent values. We can only enter the consistent values in the table. So we can improve by doing that. Definitely, the data consistency will be maintained, and whenever the data consistency is maintained, then that particular table which you have created, that table is a perfect table with all the inconsistent data that is removed. So we can easily communicate with the stakeholders. So our stakeholders are for the college, the stakeholders are students. So when we are going to maintain the perfect information about the student, then it becomes an easy communication with the students. So here in the ER model, we are going to understand what is the conceptual database design and represent data using attributes and other relationship. So conceptual design is here. We are going to create one ER diagram. So here we are in the conceptual design. We are going to create ER diagram with entities, entity sets, relationships, So relationship is one to one to many, many to one, many to many. So we are having four. If you are going to create an ER diagram with all these concepts, then it becomes a conceptual design of the conceptual database design. So we'll be discussing that. So entity is a just to recap that entity is a real-time object. It can be physical or logical. Entity is represented with a rectangle. Entity is represented with rectangle. So here different entities are student, employee, and course. So these are different entities. So types of entities, as I discussed in the ER diagram, we are having four types: strong, weak, and associate. And the example of each strong entity is represented with rectangles like this, with strong rectangle. The weak entity is represented with dotted lines, and the associate entity is represented with the association between the two entities. So the relation we are having between the two entities. So attributes are nothing but they are the property of an entity represented as ovals. Attributes are represented as ovals. So we are having the student one table. Student attribute is represented with the ovals in this way. So this is the entity. These are the attributes. Four attributes for student. So types of attributes: simple, composite, single valued, and multi-valued, and derived. So single valued means if an attribute is having a one value, like your primary key attribute, so it's having only one value. Multi-valued means we can take suppose one attribute is name is there, so that can be derived first name, second name, and last name. So this one attribute, single attribute, is can be derived, and we can have the first name, second name, third name. So if that is the case, then it is called as a multi-valued attribute. Derived attribute means one attribute is derived. Suppose the employee is there. Employee is one attribute. So part-time, full-time employee, and part-time employee. So these two attributes, they are derived. So we have to give the arrow mark like this. So these two attributes are derived from the employee table. So that will become a derived attribute. So relationship, we can show the relationship between the entities. That relationship symbol is the diamond between the two entities. So these are the two entities, entity 1 and entity 2. This is the relation. So here the student, one example we can take, student and course. So the student enrolls for the course. So the relationship name is enrolls. Okay, student enrolls for a single course, so student enrolls for the total course. So like that we can give the relationship. So then we can create a table for the relationship showing all the primary keys and foreign keys of the two tables. The two tables here are the student table and the course table. These are different types of relationship: one-to-one, one-to-many, many-to-many, and unary relationship. So we can represent the association among the entities. So here you can see student enrolls in course can involve multiple entity sets. So what does it mean? So one student is there, course is there, course is the another table, that is another entity. Enroll is the relation between the student and course. So you can involve multiple entity sets. Now you can see this relationship we can extend to another entity y. This relationship you can extend to another entity set. So this relationship, what is the relationship name? Enrolls. That enroll relationship can be extended to student, course, x, y, and z. We can also have x here. So same relation we are going to extend between the different entities and different entities. So here you can see one-to-one can be possible, one-to-many can be possible. That is student enrolls y, so one-to-many. Student enrolls, so many-to-many, many-to-many. So different relationships we can maintain between the different entities, and here the relationship name is only enroll, but we can have maintain one-to-one, one-to-many, many-to-many, many. So these are all relationship set. We will call this as the relationship set. So relation name is enrolls. Relationship sets are entity, that is student, course. So what is the relation you can maintain? One-to-one, one-to-many, many-to-one, many-to-many. Like that, the student maintains a relation with course in different ways. Student maintains same relationship with x. So that can be one-to-one or one-to-many. So many-to-many. So like that, the same relation we can extend to different entities. So what is a primary key? Primary key is uniquely identifies an entity. Employee ID is the primary key. So for any database design, for any database design, we should have a primary key first. So we should have a primary key and we should give not null. The specific meaning of not null, as I told just now, it is nothing but compulsorily you should enter a value. Whenever you are entering a data, that particular data should be entered compulsorily. Otherwise, the table will not be created. So weak entity, as I told, it has no primary key, uses the partial key and is represented with a double rectangle with dotted. So that is called as a weak entity. Now we are coming to the conceptual design of the database. That is specialization. So what is specialization? It is nothing but, so we are having one class, that is employee. Employee is the entity. From this employee entity, we are going to maintain the two different derived entities, which are called as the manager and engineer. That means we are going to classify some of the employees as manager. We are going to classify some of the employees as engineer. So what we are doing is we are dividing this one entity into the sub entity, right? So suppose we are having one relation like salary. Salary is the name of relation. So the name of the relation can be extended to, the name of the relation salary can be extended to manager. The name of the relation salary can be extended to engineer. So employee, manager is an employee who gets a salary. In that way we can say. So what is the statement here? Manager is an employee who gets salary. So salary is nothing but is your relation. So we represent that with a diamond. So engineer is an employee who gets salary. So one entity is extended into the sub entities. So in this way we can specify the relation. Now what is generalization? Generalization, you see, suppose here in one example I have taken, so it combines the entities into generalized entities. So I'll make you to understand what is the meaning of this. So here you can see vehicles. Vehicle is a entity. Sorry, vehicle is a entity. Vehicle is a entity. So in vehicle, we can specify that there are two-wheel vehicles, which is a sub-entity, three-wheel vehicles, four-wheel vehicles, and more five-wheel, greater than five-wheel vehicles. So here car and bike, they come under, car and bike come under, car comes under four-wheel. That means we can subdivide an entity into another entity. Subdivision. So car is a four-wheeler, and bike is a two-wheeler. Car and bike are, one is four-wheeler and bike is two-wheeler. They are part of the vehicle. Which type of vehicle? Car is a four-wheeler vehicle and a bike is a two-wheeler vehicle. So these two things are combined. So how it is combined here you can see. This is the way that it is combined. So we are going to follow a bottom-up approach. That means first we will specify what is a bike. We'll understand bike. Bike is a vehicle. So we can write like this. We can give the statement like this. Bike is a vehicle. Bike is a two-wheeler vehicle. I can write like this. So vehicle comes at the last because this is the main entity. This is the main entity. This is the sub entity. This is the sub entity. Sub entity, and the sub entity is further divided into sub entity. So generally, when you are going to design this generalization, what happens is we are going to start from the sub entity, that is bottom up approach. From the bottom up approach, we will go to the top of the statement. We'll go to the top entity. So bottom entity, so there are different levels. If I draw a tree like this, then I draw a tree like this. So 1, 2, 3, 4, 5, 6, 7. So generalization approach means here we will go from the bottom to the top. Whereas in specialization approach, we will go from top to bottom. This is approach. From top down approach will follow. But whereas in generalization, we'll follow the bottom up approach. So this statement, bike is a two-wheeler vehicle. Bike is a two-wheeler vehicle. So vehicle is the main class. Subclass is the two-wheeler. In the subclass, the subclass vehicle, we are having another class which is called as a bike. So we can further divided bike into manufacturing type like Hero Honda and TVS and etc. So that also we can specify. So that also comes under the generalization process. So we can say, for example, Hero Honda is a bike and it is a two-wheeler vehicle. Hero Honda is a bike which is a two-wheeler vehicle. That statement we can say. So that comes under the generalization. So what is aggregation? Aggregation is the relationship between the relationships. So like this, I will draw the diagram. Here we are having one relation. Then I am having another relation, X, Y, Z. Here I will specify A. One more relation I will specify B. One more relation I will specify C. Now aggregation is a relationship between the relationships. So there is a relation between X and Y. There is a relation between A and Z. There is a relation between. So here I am specifying only one relation. I can have more than one relationships. Okay. So this one relationship I am extending to entities called as X, A, Y, B, Z, C. One relation is being maintained by 6 entities. Suppose if I am going to say only this one. What is the meaning of that? The entities X, the entities B, the entities Z, they are in relation with relation name is 1. So this combines the aggregation. So aggregation here we will write like this. We will write the relationship name. Relationship name is 1. Entities who are maintaining the relations are X, B, and Z. So if I give like this, that means this aggregation 1 relation is maintained by Y, Z, and C. If I give total like this, then this aggregation, this relationship 1 is maintained by all the entities. So all the entities are going to participate in the relation. So we can specify. So what all entities that are going to participate in that particular relation, we can specify. So we can just give a round symbol like that, specifying what are the relations that are going to be participating in that particular relationship. So by drawing this type of diagrams with a single relationship or more than relationship. So high level database planning, I will give you one example. So here one relation is there between so I am having one more relation. I'm having one more relation like this. So I'm having some entities which are in relation with this. So if I am going to design a relationship like this, with this is called as a conceptual design. So in the conceptual design, we should understand. In the conceptual design, we should understand one thing, that we are having multiple relationships, not a single relationship. If it is a single relationship, then it is a database design. If we are having multiple relationship, like so, I will give the relationship name like this: 1, 2, 3. A, B, C, D, E. So I can say that the entities A, B, C, D, and E are in relationship with 1, 2, and 3. So if I am going to round off this like this, that means all are in relation. So multiple relationships, star to star, we can say many to many relationship. And if I specify like this, that means 1 and 2 are having relationship with the entity sets B and C. So entity set entity set, relationship set, both are different. Entity set means more than one entities are having the relationship with one another. Entity relationship means one entity, there are two entities, only two entities are having relation. So there is only one relation. In relationship set, there are having more than one relation. So 1, 2, and 3. So relationship set means more than one relation. More than one relation. Whereas in ER diagrams, we are having two entities and one relation. So normally in conceptual design, that is high level design, we are going to have more than one entity, more than one relationship set. That means there are two relations. The two relations are going to be are going to have the entities. Entities are going to, between the two entities, there are more than two relations. So what are the defined steps in ER conceptual design? Identify entities. Yes, we are going to identify in the previous diagram. You can see that we are having one relation, 1 and 2 are the relation, they are shared by B and C. So for entity B, for entity C, you are going to identify the entity set, you are also going to identify the attributes. So so when you are maintaining two relations, that means more than one attribute of each entity set are going to have that relationship. So here you can see define attributes for each entity, define the relationship. Define the relationship means define the relationship between the two entities. So how many relations you are going to have that? Specify the constraints. So what are the constraints you can give? Like the primary key, foreign key, and the candidate key. Then finally you are going to draw the ER diagram. So these are the different steps you are going to understand in ER conceptual design. So finally, I would like to conclude that by doing the conceptual design, we can definitely understand the different types of relationships that are possible in the ER diagram, and we should select those particular entities which are going to participate in that particular relation. Either it is a single relation or multiple relation. So here we are going to understand the different types of relations. So based on that, we are going to draw the ER diagram. So the ER diagrams are most important concept here, which is going to identify the different types of relationships. If we are going to have one relation, then it is called as the unary. If I am going to have two relations, If I am going to have two relations, then it is called as a binary. So the diagram which I drawn here, this is called as a tertiary relationships. That means we are having more than two relationships we are having. Binary means single, unary means single, binary means two, tertiary means more than two. So normally the high level conceptual design will be in the tertiary relationships. In tertiary relationships, we are going to consider these three important concepts which are called as the specialization, generalization, and aggregation. These three are very, very important concepts in the conceptual design of the database. So finally, I would like to conclude that if you are going to understand the relationship, so understanding the relationship means here we should identify the attributes, we should identify the entities first, then go to the attributes, then go to the relationships, then identify which relationship is suitable for which type of entities. So in that way we can design that particular high level database. Thank you.